Hey everyone, on this lesson we are going to start working with the input and output in Haskell. On the previous lesson we introduced the input and output system that we have. We saw that the main program is by definition a program that returns a type of input-output, and we also saw that the type input-output in Haskell is nothing more than a monad. Finally, on the previous lesson, we saw a brief example of this system. In this case, it is a program that basically asks the user for its name, and here it just prints the name. So here, what is your name? We just write in the console, okay, James, and then the output is hello James. Okay, so let's try to build this program and some other programs that we can make in the input and output system in Haskell. The first step is opening the console on our operating system. This is the same step whether we are working in Linux, Windows, or Mac. Okay, we open the terminal and then we move and we go to the directory where we will save the Haskell code file. So in our case, we are going to create a new file and save it inside the folder named Haskell, okay, that we have inside Documents. Here we have a folder with the name of Haskell, and we have created a new file already that we can show this. We're working in Windows and we can show the list of files that we have inside this path with the dir command. We execute, and as we see, we have a file that is empty. Okay, the name of this file, we have named it to be code. You can name any name that you want, and as we have been looking, we have 0 bytes. That's because the file is empty. We have not written anything yet. So this is the file that we are going to work, okay? And finally, with the file that we are going to compile at the end. So let's open this file. Let's clean this terminal and let's open the file code. So we are now in the code that we want. So we're using the editor Kate editor, okay? You can use any environment that you wish to program. And the name of this file is code.hs. Here you can write anyone. You can just write program, or you can write input, output, okay? What's mandatory, okay, is that the extension that you name your file needs to be HS. This represents that this is indeed a Haskell programming language file, okay? So let's try to build this new input-output notation that we have in Haskell. And let's start defining the main. The main program, as we know, returns the input-output type, okay? And now we can define the main program with the do notation. This is a notation that we explained on the section of monads. And first of all, we just print in a line, what is your name? What is your name, right? So keep in mind that this function prints a string, and at the end, it prints a line break also, okay? It also makes a line break. Then we can store in a name pseudo variable. Here we name that this is not a real variable because in functional programming we do not have variables, but they act like they were variables. That's why we call them pseudo variables. Okay, they will act like they were, but they are really not variables. Okay, so we are going to assign to the name the getLine. Remember that this function getLine basically takes the value that we write in the input and returns it. So at the end, we're going to return the input that we write on this variable. Yes, so at the end, we just print hi or hello, like the example, and then the name, and then a exclamation symbol, for instance, okay? Now, keep in mind that before compiling this program, remember that in here, you need to add the dollar symbol. Now, why do we need to add the dollar in here? Remember that this dollar basically establishes that this, okay, expression is going to be executed before this expression. So the priority of the right is bigger than the one that we have on the left. Why? Well, because imagine that you remove this. Then you will try to print a list that is not built yet. So we first need to build this list. Remember that a string in Haskell is a list of characters. So we first build the list and then we print. Okay, like so. If you erase this, you will try to print something that is not built yet. So you'll have a compilation error. So we can avoid this by basically saying Haskell first, build a list, and then print this resulting list, right? So with this, we have the program, which is the example program that we saw on the previous lesson, but now in the real practice. So let's now compile and execute this program. To do this, we go to the console, okay? And here we just have to write GHC to compile. Until now, we have been using the interpreter with GHCI, but now we are going to use the compiler. And then we write the name of our file. In this case is code.hs. We press enter and we run the compilation. So now once we have compiled this, we can execute this example and see that we have a executable file, which is code.exe. If you're working in Linux, you'll have a Linux executable file. So now to execute this program, if you're working in Linux or Mac, you just write a point, a slash, and the name code. But since we are using Windows, we just need to write the name of the program. This depends on your operating system, okay? So in my case, I'm working in Windows now, so I just write code. I press run and I press enter. So I have now the execution of the program. The first thing, as we know, is the printing of what is your name. Now Haskell waits for us to put an input. So in our case, let's just put that the name is Mark, okay? And then here it just prints hello Mark. So this works fine. So this was the example that we saw on the previous lesson. However, there are many more things that we can do with the input and output system, right? So on future lessons, we will solve problems about this, but now let's keep working and see what more we can do in the input-output notation in Haskell. So let's make a new program, and let's, for instance, write the text backwards. So here the goal of this program is to write a text backwards. So let's define the main as the do. We're going to use the do notation, right? And before continuing, it is important to know that if you don't specify the type of the function main, in this case you just erase this, then no problem will happen. Why? Because remember that Haskell has a automatic inference type system. So Haskell will basically infer the type to be a input-output, because by definition it is. You can define it or you may not define it, okay? In both situations it will be fine. So in our case, we will just leave defined as we had before. So let's continue with this program that basically writes a text backwards. The first thing that we will do is going to read one line. So let's apply the getLine function. All these input-output functions, we explained them on the previous lesson. So you can just go to the previous lesson and see those functions. And now this time, let's compute and calculate what is this line backwards. So we can apply the reverse function, which is a predefined function in Haskell, and we are going to reverse the list text. Now keep in mind that when we write a text, a string, in Haskell a string is equivalent and it is the same thing as a list of characters, right? In Haskell, a list of characters and a string are the same thing. So we can reverse this list. So the last letter is now the first one and so on for every letter that we have in this text. And now this result we will put inside a name that we call y. Next we can write the original string, so put string line x, and we can also write the put string line with the new reversed list, which is y. Now we save, right? We save this, and when we compile this now, ghc code.hs, so we wait for the compilation, and now we can test this out. We just write code because we are using Windows. If you use Linux or Mac, you just write point, slash, and code, okay? So in our case, just code. So now this program waits for us to write a string, because this is basically executing now the getLine, okay, command. So we are now waiting, the Haskell is waiting for us to write this string. So let's just put, for instance, the word cloud. For instance, we just write cloud, okay, and we press enter. And as we see, we have now the original string, okay, which is, well, in this case, it was the word cloud. And then we have the reverse text. So we have the backwards text as we see here, okay. So this works fine. So as we see, this example is very, very simple. And let's now try to extend this program in the sense of, let's try to make this program to reverse many texts that we write on each line of the program. So it is basically going to be some sort of a iterative program that basically asks many lines that we want to reverse, okay? So in here, let's just define the line to be, for instance, the get line. So here's the line that we read, or in this case that Haskell reads, right? And then let's consider that when we write the given symbol, which is asterisk, okay? So when we write this, then the program ends, and while we do not write this symbol, then the program does not end. So here we can just specify a condition that if the line that we are dealing is different from this asterisk, okay, then, and this is when we use again the do notation, okay, let's erase this. Then what we will do is that we will print the reverse line. So we put string line, and now we apply the reverse to this line that we had before. And remember, again, here you need to write and to add the $. Why do we need to add this $? Well, because now what we're printing the reverse of this list. So first we have to build this new list, which is the reversed one, and then we print. If you erase this, you will try to print something that is not built yet, okay? So we first build this, and then we print. So we use the $, right? So this is the case where we do not have this symbol, let's call it the stopping symbol, okay? So if we do not have this, then we print the reverse line, the text backwards, and then again, we have a recursive call to this same function. So we execute it again and again, okay, this same process. So otherwise, and here we have the else, right? What if the line that you read, okay, or basically that Haskell reads is this asterisk, okay? So we have, imagine that we just write this in the console. So then we have to stop. How can we stop this program? Well, we can stop it with the return, okay? Remember that this return was a monadic function that we had, and then we're just returning the void, which is the same as void in C, okay? It's the empty tuple. So this is going to end. So we save this. So let's now verify that this is working right. So let's open the console and let's compile this program, GHC and then code. So we press enter. Here, as we see on the line 7, we need to write the line that we want to compare. In this case, if the line is different from this symbol, okay, we didn't put the line variable before. So basically we are comparing if the line is different from this asterisk, which is the stopping symbol, then we are going to print the reverse line and we are going to execute again the same program. If the line is equal to this symbol, then we are going to stop the program. Okay, so let's now compile again. We just write GHC code. Okay, and as we see now, there are no compilation errors. We wait for the program to be compiled. Okay, and now we execute the code program. So basically now the program is waiting for us to write a string. So let's, for instance, write the string 3. Okay, 3. So here we have the reverse string. And now again, the program is waiting for us to write another input. So let's now write now computer. And we have the reversed computer text. And we can do this along so on, many times. We can try to put phrases, for instance, good morning, okay, good morning, and we have the reverse string. So when this program will stop? Well, basically it's going to stop when we write the asterisk, which is the condition to stop that we have specified, right? So now let's write the asterisk. So here we just write the asterisk, and as we see, the program stops. So this is another example of the input and output program that we can do, for instance, in Haskell. Okay, there are many ways that we can do and many things that we can program with this system. Very well, so with this we end the lesson on working with input and output in Haskell. On the next lessons, we will study and solve advanced problems about the input and output system.